Hey everyone, I wanted to make a video about how the new mod calibration and what it's revealed about the underlying math of mods, and then the Java kit dropped, and now I gotta do this video real fast so that I can go listen to other people talk about the kit because it looks really cool. Anyways, mod calibration really revealed a lot about the underlying mechanics to the player UI that has always been there on the back end for those that have looked, but I hadn't, and I think a lot of other people hadn't as well. Going into mod calibration, I had assumed that uh, speed rolls would show up in four different lengths: a +3, +4, +5, and a +6. And they can, but they usually don't. So for example, if we take this mod where the bars looks like I rolled a +3 and a +5, but the total mod is only a +7. So what's going on here? It turns out that every roll is a random quality from 0 to 100% that gets translated into a speed value. This first roll is just the closest I have to a 0% quality in my collection. 0.6%, or sorry, 0.06% translates to a 3.0018 speed, which then gets truncated down to just 3 speed. The second roll here isn't actually a +5, it's plus 4.94, which only means 4 speed. These add up together to be 7.94 speed, which gets truncated down to only 7 speed. All of this means that these bars aren't just increment, but they're actually ranges that translate each roll quality into a speed value, with +6 rolls requiring a perfect 100% quality roll. All of this is, very cool and interesting if you're like a data geek, but why does this matter to us? In this case, if my next slice on this mod is just a purely awful 2% quality slice, that would actually translate to a +4 speed roll. Technically, it would be plus 3.06 speed, but that's enough to bump the total speed on the mod to 11, and so it would be showing as a +4 roll. This actually changes a lot for the next roll that the mod has. Now the chances of getting a +3 roll is very small because only 2% of rolls will have the quality less than what would translate to a 3.06. And as a result, there's a much higher chance of getting a +6 roll, about 34% in this case. This explains why +6 speed rolls have always been so rare with the first speed roll. It's about 1 in 10,000, but relatively common in later rolls for a mod. Once you have a leftover fraction of speed, it's much easier to get something that would add up to +6 with that leftover fraction. Something I want to stress is that all these terms that we've used, like a +4 roll and a +5 roll, they don't exist in the game code. This mod here isn't saved with a +3, +3, +4 speed values. It's 3.00, 4.94, and 3.06. And then those are added together and truncated, and that integer determines what the speed value is in game. To get the exact speed value, you actually have to have access to back-end game data or use a service like HotUtils, which just today added visibility for speed remainders. But we can also get pretty close using this average slice quality metric shown here in the UI. So both of these mods, I've shown their percentages and their true speed amounts from the back end of the game, and add up to 9.8 and 12.2. The formula for determining a mod's speed from quality would be you take the average quality multiplied by 3, you then add on 3, this being the minimum that every roll will give you, multiply that by the number of times that the mod has sliced on speed, and then add an additional 1 if it's a 6-dot mod. I should give major credit to Wookie Town on the Grand Arena Science Discord. He was the person who first brought this attention to the community when calibration came into the game. He's the one who figured out this original formula, and then there's been a lot of work done since then by numerous members of the community. Using this formula, we can take this 64% average slice quality, plug it in, and plug in the number of speed slices, which in this case is 2, and we get an equation that results in a 9.84. That tells us this mod is 9 speed, which checks out, with 0.84 leftover speed, so a lot. This mod will have a good chance of rolling slightly higher on the next roll. In contrast, there's this mod that has several speeds that are all right around 4, but at different points. If we put the numbers into the formula, we get 12 speed with a 0.204 leftover speed, a lot less than the other mod. I made a calculator that gets at this exact same content. And so showing here, if we took this mod, make it a 5 dot, has 2 speed rolls, and it has a quality metric of 64. This would tell us the same information. We have a current speed of 9, we have 0.84 leftover speed, and then this would be the percentage chance of getting each of your rolls. The +3 and the the +4 and the +5 roll are always going to be 33% chance each, and the remaining 33% chance will be split among the +3 and the +6, depending on how big your remainder is. As this remainder decreases, the mod would be more likely to roll a +3 on the next roll and less likely to roll a +6, until at some point it would have been only an 8-speed mod with a high amount of excess quality or speed remainder left over. I'll drop the link to this tool in the description below. I should say that I'm running into hosting costs on it, and so it might not stay up for forever, but I'm hoping to find other solutions for that. I also have a Patreon that I recently set up, and if you're looking to chip me a couple bucks, I'd really appreciate it. Anyways, I'm going to get back to going to read all of Java's kits, so have a good one.